Hi, how are you doing? Welcome to today's lesson. What we're looking at today is the Pythagoras Theorem. Right, so Pythag. Now, with Pythag, it's a very powerful theorem that allows you to work out the length of sides of a right-angled triangle. It only works for right-angled triangles. Okay, please don't try this for other triangles. When you get more advanced, you start looking at trigonometry, you'll be able to work out the length of the sides for any triangles using the cosine rule. That's a version of Pythagoras. When you understand it well, you'll see that it is. But for now, only right-angled triangles. So the story is this. If I have a right-angled triangle, any right-angled triangle, there, and let's call this side x because it's horizontal, let's call this side y because it's vertical, let's call this side r, because I pretend it's as if it's a radius of a circle. If I had a circle that I could trace out along here, alright, I could trace out a circle all the way around as that the radius. So let's just call it r. Okay, when you get into trigonometry a little bit later and you look at the unit circle, you'll see why I like to call it r. But for now, x, y, and r. Okay, you can also call it, and I have seen this done before, especially for a different way of learning trig. If you don't want to stick with a Cartesian plane, you can also call it the adjacent, the opposite, and the hypotenuse. Alright, so that's another way of doing it. Or you can call it ABC, or you can call it whatever. I'm going to stick with x, y, r. I'm going to stick within the xy axis. And what Pythag tells me is this. R squared, the hypotenuse squared, equals x squared plus y squared. That's Pythagoras. In a right-angled triangle, the long side squared is equal to the two shorter sides squared added together. Okay, or the sum of the squares of the shorter sides. Okay, or the two straight sides. Now, this is very straightforward because it's just plugging into the formula and working things out. So let's take a look at an e.g. of a Pythagorean triplet. Now, a Pythagorean triplet is one of the common ones where it works out nicely to whole numbers. Most of the time, because I'm going to have to be using square roots to get rid of the square, it's not going to work out to a nice whole number. But let's look at this one. So, this is one of the Pythagorean triplets, which I've drawn completely disproportionate, so I'm going to try that again. Let's do it this way. That's slightly better, not much. So let's call this side 12 centimeters, let's call this side 5 centimeters. And they say, how long is this side? Let's call that r for the radius of the circle. Okay, so very straightforward. It's a right-angled triangle, okay, and all I'm going to do is I'm going to write down Pythag. So the right-angled triangle, r squared equals x squared plus y squared. Please do yourself a favor and write that down every single time. That is Pythagoras. Pythag. That's the shorthand. Okay, so Pythagoras. Alright, so there is the equation. Now all I'm going to do is take my two sides and put them in there. Okay, and this is important, I've got to put them in the right position. So r, well I don't know, so I'm going to leave this r squared equals, well x is 12 squared, with me, or make it look a little bit better, I substitute 12 like this. Okay, y is 5 squared. Okay, so now we work out 12 squared is 144, plus 5 squared is 25, 144 plus 25 is 169, okay? That equals r squared. It does not equal r, alright? So that equals r squared. Now, to find out how long r is, we have to do the opposite of squared, otos, opposite to other side, okay? If you've watched any of my other videos on how to solve equations, I use this, opposite to other side, okay? So opposite of squared is square root. So r equals the square root of 169, which gives you r equals 13. Okay, so in this length, r equals 13 centimeters. Now, because of the square root thing, most of the time, you're not going to get nice whole numbers. You're going to have to round this like 1 decimal place or 2 decimal places if you're using a calculator. Okay, if they give you a nice one, a Pythagorean triplet, this is one of them, 12, 5, 13. The other one is 3, 4, 5, which is a very cool one, okay? If they give you a nice Pythagorean triplet, then you might be getting something like this in a non-calculator paper, where you expect to be able to know this. Alright, the square root of 169. This is why I tell my kids, it's always useful to know up to 15 squared. 15 squared is 225, okay? So the first 15 square numbers, alright? So this is one of them. 13 squared is 169, okay? I would totally put this in a non-calculated paper for you to be able to work out. Alrighty, but that's about it. Take the two straight sides, substitute them in the right position, there you go. We're going to look in the next video on the other page about when they give us the hypotenuse and we have to work out the others. A very small difference, but it's a difference that I think is important enough for us to separate out from this. I get a lot of kids, especially in year 7 and year 8, who get that small concept of mistake. Okay, and we'll deal with that in the next video. Alright, but come watch this again if you need to. It's very straightforward. Go practice a couple of these, and remember, I'm always here for you.